Welcome to This Explainer. You know, it's so easy to just abstract the web into this magical cloud, but today we're decoding the actual physical hardware that makes the internet tick. Because underneath every single connection, there's a tangible, physical machine stretching literally from the plug in your wall all the way out to a massive global network. Think about it for a second. How does an email actually travel from your laptop out into the wider world? Well, it behaves exactly like physical traffic. Your data navigates local roads, busy intersections, and massive high-speed global highways. And understanding those physical roads and intersections, that's what really brings the whole digital world into focus. So here's our roadmap for today. First, we'll look at making the physical connection. Second, boosting and extending signals. Third, connecting local devices together. And finally, navigating between different networks. All right, let's jump right into part one, making the physical connection. These are our fundamental building blocks. You've definitely seen one of these before. The RJ45 connector is the absolute standard interface for hooking up Ethernet cables to your computer or router. It's got exactly 8 pins tucked inside that little modular jack, and it follows some highly specific wiring schemes. Why? Because that's what guarantees the super reliable, high-speed data transmission we rely on for wired networks everywhere. But hey, what happens when you need to change the type of road your data is traveling on? Well, that's where a media converter comes in. This is a slick little device that connects entirely different types of cables. Let's say your standard copper cable just isn't cutting it for length, or maybe you need the blazing fast speeds of fiber optics. The media converter literally steps in and translates the electrical impulses from the copper wire into actual pulses of light for the fiber optic connection. Pretty wild, right? In the real world, these managed media converters act as absolutely crucial infrastructure. You'll find them working quietly behind the scenes in schools, corporate offices, and those massive data centers. They're basically bridging entirely different physical network cables together seamlessly, all without dropping a single packet of data. Moving right along to part two, boosting and extending signals. Let's talk about extending our reach. So here's the problem. Over long distances, signals naturally degrade. If a wireless router is just too far from a computer, the connection fades out. Enter the repeater. Positioned right in the middle, this device catches those fading signals, regenerates them back to their original strength, and sends them right on their way to their destination. Think of a standard plug-in Wi-Fi repeater exactly like a range extender. They're basically the gas stations, or maybe relay runners is a better way to put it, of your network. They boost those data signals so your video stream or giant file download doesn't just buffer endlessly when you're sitting, 3 rooms away from the main router. All right, on to part 3, connecting local devices together. Let's build a local network. First, let's introduce the hub. A basic multi-port hub is designed to connect different computers on a local network. It's simple, it's super easy to install, and it's cheap. But there's a major catch here. A hub is, well, very basic. It actually has no idea who the incoming information is meant for, so it just blasts it to every single connected computer all at once. It's honestly a lot like shouting across a crowded room just to get one person's attention. Now, a modern network switch looks pretty similar, but it is far more sophisticated. It also joins multiple computers together, but it actively coordinates the traffic. So instead of shouting to the whole room like the hub does, the switch ensures that only the specifically targeted computer receives the intended information. To put it plainly, let's just compare them directly. Hubs, simple, low-cost, and completely uncoordinated. Switches, targeted, coordinated, and because they don't clog up the network with unnecessary traffic, they are incredibly faster. This targeted data sharing acts like a highly efficient, smart intersection processing local traffic. And honestly, this is exactly why switches have largely replaced hubs in almost all modern networks today. Okay, final step. Part 4, navigating between different networks. Let's zoom out to the macro level. First up at this macro level is the network bridge. This device interconnects 2 computer networks that are operating on similar protocols. It basically acts like a border checkpoint. It carefully inspects incoming signals and makes a split-second, crucial decision. Either forward the data across the bridge or just discard it entirely. But what if the networks are vastly more complex? Well, that's where the router comes in, going a massive step beyond the bridge. It's an intelligent device that connects multiple wired or wireless networks, and it functions entirely on the principle of Internet Protocol, or IP, addresses. By calculating routes based on these IP addresses, the router acts like a global GPS system for your data. A modern multi-antenna wireless router serves as the absolute central intelligence of the whole operation. By reading those IP addresses we just mentioned, it dynamically figures out the most efficient possible path for data transmission. It navigates across the myriad of networks that make up the internet, adapting in real time just to get your data exactly where it needs to go. So we've gone from the RJ45 cable in your wall, through media converters and switches, all the way up to the intelligent routing that maps the entire globe. But as our need for speed grows exponentially with new technologies, what new physical hardware will eventually replace the router? What's going to redefine how our data travels next? I mean, will it be quantum networking? Or maybe something we haven't even dreamed of yet? Keep exploring the incredible physical systems that power our digital lives, because the hardware of tomorrow is literally being built today. Thanks for joining me on This Explainer, and keep your curiosity hungry.